Next is the periodic table. We know the elements have what physical properties as well as what chemical properties. Here the chemical properties of the elements are determined by the atom number and arrangement of electrons in the outermost shell. Then the atoms having same number of electrons in the outermost cell have same chemical properties. This is the basis for the periodic classification of elements. Then the periodic table, it relates the periodic properties and the lowest energy electron configuration of atoms. Then when elements are arranged in increasing atomic order, that the elements having same chemical properties and physical properties, they repeat at regular intervals. This was given by Mendeleev, and this is called the periodic law. It was given in a table, that is they are arranged in a table, and the table exhibit the periodic properties, and this table is called the periodic table. Then you see the table. In the table there are many group of elements, that is group 1 element, the next group 1, group 2, like that there are many elements. First this group 1, you see, it consists of first hydrogen, then what alkali metals, that is lithium, sodium, potassium, rubidium, cesium, francium. Then these have valency plus 1. Valency means what are the number of electrons in the outermost cell, and they are chemically active. Then next see the group 7. The group 7, it consists of halogens. Then they have valency what -1. They are active non-metals. Then next group is 8 elements. You see, this group 8 elements are inert gases. Then they are inactive elements. Therefore these group 8 elements, they are inactive, therefore they do not form compounds with other elements, or they do not form molecules when they join together. Then next see the horizontal row. The horizontal rows, they are called periods. There are 7 periods, 1, 2, 3, etc. to 7. Then the periods are numbered as 1, 2, 3, 7. Then after the third period, you see there appears a series of elements, that is in between group 2 and group 3 elements. These elements are metals. Then these elements have progress filling with the electrons in the d orbitals. Then going from left to right. The next in the period 6, you see in the period 6 there are 15 elements. Their atomic number ranges from 57 to 71. They are indistinguishable in their properties, therefore they are called lanthanide elements, or they are called rarets. Then next in the period 7, you see there are elements from Z equal to atomic number 89 to 103. They are closely related metals. They are called actinides. Therefore then to understand these elements in the same group have, we have studied these elements in the same group have similar properties. Therefore we consider the electronic configuration of that halogen atoms. Then in the electronic configuration, you see the next diagram. In the electronic configuration, you see fluorine, chlorine, bromine, iodine. These are the halogens. Then these halogens have same number of electrons in the outermost cell. Have you seen 5 plus 2, that is 7. Here also 5 plus 2, 7. 5 plus 2, 7. Therefore there are 7 electrons, same number of electrons in the outermost cell. The next this alkaline metals, they have 1 electron in the excess into of completed cell. After completing the cell, they have excess 1 electron. Then halogen elements have they have their lack of one electrons, that is they do not have one electron, therefore they want one electrons to complete the shell. Then so these halogen electrons they combine with alkaline elements, then they form a compound, that is a stable compound. Thus, this vector atom model, together with the Pauli's exclusion principle, this enables to understand the periodic classification of elements.